Hello everyone, welcome to iitiansgateclasses. Am I audible? Guys, please respond in chat, those who are watching this session. Am I audible? So myself Dinesh guys, and in this session we'll be going quickly through space dynamics questions from GATE 2024 Aerospace Engineering exam. So these are the details about our courses for GATE 2025 and 2026 guys. So guys, for space dynamics, there are total three questions, and all three questions are easy question, guys. Okay, and I think two questions are very much related to previously asked question also, and the question which was asked about geostationary orbit, also, you know, a few years back, similar questions, or there is a question on geostationary orbit. So let's see this first question, what it says. Which of the following statement is or are correct about a satellite moving in a geostationary orbit? So, guys, about geostationary orbit, those are like orbits which have very high altitude. Okay, and those orbits are used for what? Like if you want to focus on Earth at a particular place, then the satellites are launched in geostationary orbit. So what it is saying, the first option, the satellite is visible from all parts of Earth. No, this is not correct about geostationary orbit. The orbit lies in the equatorial plane. Yes, geostationary orbits lies in the equatorial planes. Correct. The time period of motion is 90 minutes. No. If I believe, Jitesh, what is the time period for geostationary orbit? Anybody else? Those who are watching this session can answer quickly. What is the time period for geostationary orbit, guys? Yes, very good, Neil. It's a 24 hours. It is 24 hours, right? So geostationary orbit and Earth have the same time period, okay, of one revolution, right? So this is not correct. What is D option says? The orbit is circular about the center of Earth. Yes, geostationary orbits are circular orbit. So what happens? The first satellite will be launched in LEO, low Earth orbit, and then using Hawkman transfer, they will be transferred to geostationary orbit. Okay, clear? So the option B and D are correct. Clear, guys? Any doubt? I think most of you have done correctly, right? Neil, you have done correctly. Jitesh, Yash, others, have you guys done this correctly? Okay. So let's move to next question. What it says. At a point in the trajectory of an unpowered space vehicle moving about the Earth, the altitude above the mean sea level is 600 km, and the speed with reference to the coordinate system fixed to the center of mass of the Earth is 9 km per second. So they have given the speed of the object. Assume that the Earth is a sphere with a radius of 6400 kilometer, G into M. So G is gravitational constant, M is earth of mass is given as 3.98 into 10 to the power 14 meter cube per second square, where G is the universal gravitational constant and M is earth mass. Okay, the trajectory is, guys, so in this case, guys, what all information they have given? They have given altitude h above mean sea level. See how much it is, 600 kilometer. They have given earth radius re, they have given, which is how much, 6400 kilometer. They have given gm value, gme. Okay, how much it is? 3.98 into 10 to the power 14 meter cube per second square. They also gave, guys, the velocity of object, which is given as how much, 9 kilometer per second. Now, guys, they asked the orbit, that object is in which trajectory. So, guys, we know, okay, from our basics of orbit trajectories, what we know, guys, if your orbit is in circular orbit, then, guys, at any altitude, what should be the speed of object? It should be under root gm e upon re plus h. So if your object is in circular orbit at any altitude, this would be the speed of the object. Now, guys, this is for circular orbit. Now, if your orbit is in parabolic trajectory, what will be your velocity? V parabolic is under root 2gm upon re plus h. So, your orbit will be parabolic. Okay. Now, if any object having velocity which is between vc to vp, what is your orbit, guys, or what is your trajectory? If velocity is lying between vc to vp, your trajectory is what? Elliptical. And the last case, if the given velocity v is greater than vp, then your trajectory is what? Hyperbolic. Okay, so this is what basic behind this question. Now, guys, find out, all the data are given for this given altitude h. Find out vc. So how you find vc? Substitute all the values, given values. So it is 3.98 into 10 to the power 14 upon re is 6400 plus 600. So it is 7,000, right? 6,400 plus 600. So it is 7,000 into 10 to the power 3. So what we get from here? We get 7650 meter per second. So that means if at that altitude your object is in circular orbit, velocity should be 7.650 kilometer per second. But this given velocity of object is how much? It is 9 kilometer per second. So that means the orbit is not circular. Now, if you want to find v parabolic, so v parabolic is always under root 2 times v circular. And from here, if you find v parabolic will be coming how much? 10.8193 kilometer per second. So that means your given velocity, the given velocity is lying between what? Vc and Vp. So what is your trajectory? What is your trajectory, Nielsa? Yes, what is your trajectory? It is an elliptical trajectory. Clear? So, what is the answer? The correct answer is B is the correct answer. Okay. So, let's move to next question. What it says? Yeah. Question number 48 is from IGC paper. Consider an artificial satellite moving around the moon in an elliptic orbit. The altitude of the satellite from the moon's surface at the perigee is 25 km, and that at the apogee is 134 km. Assume the moon to be spherical with a radius of 1737 km. The trajectory is considered with the reference to a coordinate system fixed to the center of the mass of the moon. Okay. The ratio of the speed of the satellite at perigee to perigee to at the apogee is. So basically what they ask in this question, they ask the velocity which is at perigee by velocity at apogee. Okay. Now guys, here instead of earth, the center of attraction is moon. So suppose moon is here, so the nearest point to moon will be what? Will be easy, and the furthest aft point from moon will be what? Apogee. Okay, so this is apogee and this is perigee. Now they have given altitude, okay, and they have given radius of moon, right? So that means altitude means they have given these values. This is h perigee, and they have given this distance, which is what? H apogee. So guys, the first thing here what you have to find, you have to find what? R perigee and R apogee. So R perigee will be what? It will be 34 plus how much is the moon radius? It is 1737. And what will be R apogee? It will be 1 not 34 guys. It is 25. It is 25. So it is 25 plus 1737, and R apogee is how much? It is 134 plus 1737. So guys, once you know R perigee and R apogee, we can find eccentricity of the orbit. So what will be the eccentricity of the orbit? E will be what? Always guys, it is R apogee minus R perigee upon R apogee plus R perigee, because E is always less than 1. When you substitute these R perigee and R apogee in this, your eccentricity is coming how much? 0.030. Okay, 0.030. Is it correct, Neil? Please guys check. Surya, is it correct? Others also, please check. Once you know the E, we guys know eccentricity can be also written. You guys can refer the IGC formula sheet in terms of perigee and apogee velocity. So what is E? Basically, E can be written also as what? V perigee minus V apogee upon V perigee plus V apogee. Okay. From here, we already know E, or you can write guys V perigee upon V. Guys, in recent year, there is one question where they asked E, but they gave this ratio. But in this year question, you know E and they asked this ratio. So that's how this question got changed. But otherwise, conceptually similar. So V perigee upon V apogee will be what? It will be 1 plus E upon 1 minus E. Okay, just multiply, rearrange. So you'll get this formula. So For any elliptical orbit, the ratio of velocity at perigee to velocity at apogee is always 1 plus e upon 1 minus e. Now, what is the e value? It is 0.03 and 1 point minus 0.03. So, from here, this ratio is come out to be 1.061, 1.0618. Now, what, how many decimal? They ask 2 decimal round off. So what will be the answer? The answer will be 1.062 is what V perigee upon V apogee. Is it clear? Is it clear, everyone? Yes or no, guys? So these 3 questions only from space dynamics they ask, but there is one acceleration related question, guys. That is from engineering mechanics. That is not from space dynamics, guys. From Newton's law. Okay, and I think there is one question on vector algebra that is also from space engineering mechanics, and there is one question which was related to finding area, that is also engineering mechanics question. Okay, so that's all for space dynamics session, and next session at 6:45 it will be for engineering mathematics section. Okay, so these are our details for upcoming batches, and these are our achievements. You guys can see we are the #1 institute in India for gate aerospace, and this year also will have so many rankers. We are pretty sure iitians will rock. Okay, and these are our PSU achievers. So those who are looking for perfect and very sincere and right guidance for gate or any PSU related for aerospace engineering can contact us on these numbers. Okay, and you guys can follow us on different social media or can join our Telegram group for past and future updates. So thank you guys for this session. So I'll just share the upcoming sessions link